Excellent. Let's have a look at some of these definitions. Now, by the way, I think this is really cool. When I was walking around, pretty much no one had exactly the same sentence. Even though you all mostly had a sentence, some more helpful than others. But this idea of symmetry, it's very common. It's not just common to young people, but it's actually a really important idea in the study of beauty, right? They say, there's studies actually out there which say that things which are symmetrical are things which we view as beautiful. And in fact, you know, when you say, oh, someone's really good looking, one of the things, the qualities that they say good looking people have is that their faces are very symmetrical. And when a face is not quite symmetrical, we can't put our finger on it, but we say, sorry buddy. You know, not the most beautiful thing. So, symmetry is a super important idea, and it's really, really profound. Let's have a look at some of these ideas. When you halve the shape, and both sides are equal. Okay, so the idea is you've got a shape like this or something like that. Okay, like this. And if you chop it in half, both sides are equal. So if I sliced it like this, then you've got this side, and they're kind of, well, not on mine, but they're meant to be equal. All right, I think that's a good idea. Let's keep going. A shape has symmetry when it reflects on the other side of the symmetry line. Okay, hold on. Lots of words here. Whose was this one again? Yes, well done, Amy. Okay, so if I come back to this diagram, I guess we would call the symmetry line a bit like the line that we use to halve the shape, right? This guy. He seems important, okay? And it reflects on the other side, and you get the exact same on both sides, so it's like a mirror. Oh, okay. So it's like this triangle over here is looking at a mirror, and this is what the reflection looks like. Okay, cool. A shape has symmetry when you can draw one or more lines through the center. That's a different idea. And all parts are equal. Okay, where would the center of this shape be? Maybe somewhere like this. Okay, so you gotta draw a line through it. Last one. You put a line through the middle of the shape. Okay, that's again getting at the same idea. The other side is reflected. Okay. I think these are all really good. They're all getting at the idea. They're all correct. I want to give us a little more detailed definition, and I want to connect it to what we looked at over the past couple of days, right? What have we looked at under geometry? What were the first things we looked at? Do you remember what they're called? Yeah. Yeah, translation and reflection and rotation. And all of those together, they're called long frames. Transformations, that's right, okay. So I'm going to write a definition for you that's in terms of those, and I want you to copy it down and we'll discuss it. Okay, so here we go. Here's my definition. A shape has symmetry if you can transform it and get back exactly the same shape in exactly the same place. Okay, let's unpack this. Okay, now we know what the transformations are, okay? So if you take one of the transformations, let's take reflection, okay? If I apply it to this shape here, right, I think there's a straight line that I can run through this so that if I apply the transformation, I just get back the same shape in the same place. That's really important, okay? So if I take my triangle again, right? And now the instructions I gave you were, reflect this triangle. You know, this would be A, B, and C, okay? And I gave you a straight line. Now before, we looked at straight lines which were like over here and outside the shape. But if I draw this line through the shape, just like I had before, I draw a line through like that, what will happen? Now this is actually important that you draw this shape with me, because go through the process of reflection, okay? For instance, A. Look at A. When I reflect it, it's going to become a new point. Before we called it A1. Where will A1 be? Where's it going to go? If I do the same way that I do reflection before, I go this distance, right? And then I look at the opposite side of the line in the same length, right? So my new copy of A, A1, is going to be over here, on top of B. In exactly the same way, B is going to reflect across the line and become B1 over here. Okay. Where does C go when you reflect it? C doesn't go anywhere, right? Because it's on the line of reflection. Okay, so C and C1 are on the same spot. Okay, so now our shape, well, the points, the corners are in a different order, right? They're sort of back to front this way, but it's the same shape in the same place. So we say this shape has symmetry. Okay, now hold on, stay with me. I said if you can transform it, right? But we know there is more than one kind of transformation. You already told them to me. There's translation, and reflection, and rotation. So this symmetry here, which we got from reflection, is one kind, right? You can reflect. But you can also rotate a shape and get a transformation, right? So, for instance, can you think of a shape so that if you rotate it in some way, you'll get back exactly the same shape in exactly the same place? Yeah, Alina. A circle, great. If I draw a circle like this, right? And I say, look, let's rotate it about the point, and I pick this point in here, right at the middle of the circle, okay? Well, how do you rotate something around? Okay, you take a few points, like maybe we'll call that one A, and B, and C, maybe, right? And if we rotate it around, for instance, if I go around like this, let's go this number of degrees, however far that is. Okay, so this line's going to go there, and this line's going to go there. Okay, so now I've got A1 and B1 and C1. Okay, but when I draw the circle that goes through all these new points, it's the same circle I had before. It's the same shape in the same place. Okay, now this is a kind of symmetry as well. We call this one reflectional symmetry or line symmetry. That's an important kind of phrase. You want to put that down. Reflectional or line symmetry. Why do you think it's called line symmetry? Because when you're reflecting, yeah, the line is the piece that tells you where you do your transformation. And in the same way, this is called rotational symmetry. Now, just like this is line symmetry, what do you think we might call this as well as rotational symmetry? It's not a line that we're rotating around. It's a point. So we also call this point symmetry. Okay? Now, these kinds of symmetry are really cool. We're going to explore them in a little more depth. Today we're just going to look at this one. Next time we'll look at this on Friday. Okay? So, here's what we're going to do. We're going to get some pieces of paper out. Okay? Now, I'm going to ask you to create some symmetrical shapes with these pieces of paper and some scissors. Here's the way you're going to do it. Okay? On your piece of paper, right? Now, what you're going to do is you're going to fold it. Okay? Now, this is really important. Once you fold it, okay, there's now a line down the middle of my paper. Okay? A line like this. This line is really important. This line that I'm reflecting across, that everyone's been talking about here, you know, middle, center, all that kind of thing. It's so important, it gets its own name. It's called the axis of symmetry. Okay. Now here's the important thing, right? Shapes, well, some shapes are not symmetrical at all, right? Here's my pair of scissors. My pair of scissors is not symmetrical, okay? There is no line that you can draw through it such that if you reflect it, you get the same shape in the same place. So some shapes have no axis of symmetry. Some shapes have one axis of symmetry, okay? And still others will have lots of different, and there's a plural word, lots of different axes of symmetry. Okay, so get this, axis, that's the singular. That's when you've just got one. Okay, you can have one axis, but if you've got lots, if you can draw lots of different lines and reflect across and get the same shape in the same place, you have many axes of symmetry. Okay, singular, plural. Now, once you do that, okay, you're gonna draw your, cut your line across here. Sorry, fold your line, okay? And then I want you to cut a shape, okay? Now here's the cool thing. If you cut across this line, any shape you like, okay? For instance, I might cut this. Let's see if I can do this. Here we go. Okay, so I've cut a shape out, right? But when I unfold it, I should get a symmetrical shape.
Thank you, Miss.
Okay. Oh, you're welcome. It wasn't for you. Now, what you got there is a symmetrical shape. Okay. We're gonna do this a couple times for everyone. You can do some interesting shapes, right? Here's one. There you go. You can see that, right? And you can see there's the axis of symmetry. Okay. But you can do interesting things. That's a bit boring. It's a bit straight. You could do something like this. This is still symmetrical, and you can just barely see the folds. Right? You can even do some shapes that are disconnected. Okay, so you can see, if I do it this way, okay, there's the axis of symmetry, depending on what you cut. Okay, so here's the way we're going to do it.